So now we're going to focus more on quadrilaterals instead of just any polygons. And reminder about what we've already discussed about quadrilaterals. We have four sides, four angles. The sum of the interior angles is 360, and then the sum of the exterior angles is also 360. As we go throughout the rest of this unit, we'll be talking about these other specific types of quadrilaterals that you see in this diagram. This diagram is also on one of your handouts for the proof cards that you should have gotten in class. So today in this video we're going to focus on parallelograms. All right, so parallelograms, by definition, a parallelogram is a quadrilateral with both pairs of opposite sides that are parallel, and you should see that on your proof cards. Okay, so that's what, by definition, what we mean by a parallelogram. But we also know lots of other properties about parallelograms. So if we look at a parallelogram, then it has opposite sides congruent. Okay, so that doesn't mean that they're all the same, but it means just the opposite sides are congruent. Okay, we also have that the opposite angles will be congruent. So for example, if this is 60 degrees, then this is also 60 degrees. And then this would be 120, and this would also be 120. And the way I was able to do that is because I know the next property, and that is that consecutive angles are supplementary. So consecutive angles are ones that are right next to each other, so they share the same side. Okay, so P and S are consecutive angles. So those always need to be supplementary. So if this is 50 degrees, this has to be 130 degrees. All right, and that's why we have 360 degrees in a quadrilateral. So the next one, the last property that we know about parallelograms is that the diagonals bisect each other. Okay, so M is the midpoint of each diagonal. So M is the midpoint of QS, and M is also the midpoint of PR. Notice that we have different tick marks, so it doesn't mean that those diagonals are congruent to each other. It's just that they're split in half. All right, so in future problems and in proofs, you will know that these properties are true if you have a parallelogram. Now the next part is, how do I show that a quadrilateral is a parallelogram? Well, we have 6 ways that we can do that. And it's kind of the opposite of those properties that we just did. So if I can prove both pairs of opposite sides are parallel, then that's just the definition. Okay? If I prove that both pairs of opposite sides are congruent, that's that first property that we talked about. And then if I can prove that both pairs of opposite angles are congruent, then that's the next property that we talked about. And then the consecutive angles, here's how we can do that. All we have to do is show that one angle is supplementary to both consecutive angles. So if I have a quadrilateral and I know that this is 50 degrees, if I can show that this is 130 and this is 130, then I've shown that that the consecutive angles are supplementary. So that's another way to show that it's a parallelogram. I don't want to just be restricted to one of them. Let's say I didn't know that one. If I just know that one, then all I know is that these sides are parallel, and then I don't know that this side is. Okay, that side could go like that, and then I don't know it's a parallelogram. So be very careful with that. Make sure you show that it's consecutive to both angles, that's supplementary to both consecutive angles. Another way is you can show that the diagonals bisect each other. So if you can prove that the midpoint is for both of those diagonals, you can show that they bisect each other. This last one is a unique one for showing that it's a parallelogram. So if I show that one pair of opposite sides is both parallel and congruent, then I can also say that that's a parallelogram. So you have these 6 ways, and you can see those on your proof cards. So let's actually apply these properties and see what we can do. So one way you might be asked to do this is using coordinates. So if I have these coordinates of a quadrilateral, so I have 1, 3 is A, 3, 5 is B, so I have A, B, C is 9, 1, and then D is 7, -1. So I'm trying to show that that is a parallelogram. And I'm just checking my vertices, making sure I graph them correctly before I move on. 7, okay. So what we can do is, we can do lots of things. If I wanted to show opposite sides parallel, I could use slope. So I could find the slopes of all of them. If I wanted to show congruent sides, then I can use distance formula. If I wanted to show that the diagonals bisect each other, I could show that the midpoint, so diagonals bisect. Then I can show that the midpoint is the same for both BD and AC. So we have lots of options to show that this is a parallelogram. I would stay away from opposite angles congruent or consecutive angles or supplementary because we can't really measure these angles on a coordinate grid. So you want to stick to slope and distance and things like that. Okay, so let's just do one of them for now. And if you had a question about how one would work, we can ask that in class. So I'm just going to do the first one. Let's do slope. That one's pretty easy to do visually. So the slope of AB is going to be up 1 over 2. And then the slope of DC, remember that's the opposite side, that's up 2 over 2. Which is 1. So already I'm getting that the slopes are not the same. Did I do that incorrectly? Let me, so 1, 3, 1, 2, 3, and then 3, 1, 2, 3, 1, 2, 3, 4, 5. Ah, that's what I did wrong. B should be up here at 5. Now that looks a little better. I thought that might have been wrong. So let's go back and reevaluate the slope of AB. So now here's B, that is up 2 over 2. So there we go. Those are the same slope, so now we have to do the other sides. So that's one pair of opposite sides that are parallel. All right, so the slope of AD, if I count, this is down 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6. All right, so that's down 4 over 6, which reduces to -2/3. And now I'll do the slope of BC. Okay, so that's going to be, I'm going to start at C now. So that's up 1, 2, 3, 4. And then to the left, 1, 2, 3, 4, 5, 6. So that's 4 over -6, which is the same as -2/3. So I've just shown with my mathematical calculations, the algebraic part, that is actually a parallelogram. So that's one way to show that a quadrilateral is a parallelogram. But we can also do a proof, and I know you guys don't like them, but that's okay. Let's do this. So we are given that HD is equal to DN, and that the measure of angle 1 is equal to the measure of angle 2. All right, so let's write that in our proof. Oh. We want to write our given, which is HD equals DN, and that the measure of angle 1 equals the measure of angle 2. Okay, and we're trying to show that this is a parallelogram, so we still have those 6 ways to show that. So let's talk about Why would that make this true? I'm sure you guys are probably itching to write those vertical angles. Let's go ahead and call those 3 and 4, angles 3 and 4. And then why would that help us? Well, then that would make this triangle and then this triangle congruent to each other. All right, so we could do a few things, but what I would say is if we focus on the diagonals, we already know that one diagonal is bisected. So we could say by CP-CTC that that segment and that segment are congruent, which means that is also bisected. So let's go with the diagonals or bisected route. All right, so in order to show that those are congruent triangles, I need these to say congruent, not equal. So I'm going to say that right off the bat. Definition of congruence. Okay. Then we also said, when we were going through that, we said that 3 and 4 were congruent because those were vertical angles. And that's a theorem. And the reason we were liking that is because then we could say these triangles, that would be HDM, is congruent to NDT. So HDM, triangle HDM, is congruent to triangle NDT. And that reason is the angle side angle. That is important because now we can use CP-CTC. So now we can say, all right, MD is congruent to DT, and that's by CP-CTC. And the reason we cared about that is because it shows that both diagonals are bisected. So we can say MT is bisected, and the other diagonal, HN, is bisected. Again, the reason we know that's bisected is because the definition of bisects. And then we can say what we were trying to prove. So we can say, I need all the letters. I need to go back up to the letters. We can say MNTH is a parallelogram. And just so you know, an abbreviation for parallelogram, instead of writing out the word, you can draw a small little parallelogram. So that's a shorthand you can use. So MNTH is a parallelogram. The reason we know is because if diagonals are bisected, it's a parallelogram. That's from your proof card. Okay, so that's the only new, this one right here is the only new reason that we would have. Okay, so that's how you can use these properties of parallelograms to either show something's a parallelogram in a coordinate plane or write an actual proof.